Geometry 1, Chapter 2 Test, Topic 9. Proofs, both two columns and flow proofs. Proofs are a significant portion of your Chapter 2 test. So being able to come up with some proofs, to complete proofs, to fill in the blanks, and proofs is extremely important to doing well on the test. So we have one proof here. We have 3 to go over. Angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. And we're going to prove that angle 2 is congruent to angle 3. And we're going to start with a 2-column proof. Looks something like this. And we have our statements go on the left side. And on the right side is the reason, or it could be titled justification, something of that sort. So there are a couple of different ways to approach proofs. My personal preference is to start with one of the givens. See, there are 2 different givens here. I like to start with one of them. So we label it number 1 and we state the given. Angle 1 and angle 2 are complementary. Now, in the reason column, how do we know that angle 1 and angle 2 are complementary? Well, we know that because it's given to us up here. So your first reason is given. Now, you could go ahead and state the second given also, but my personal preference is to go ahead and use what we just wrote. So what? Angle 1 and angle 2 are complementary. What does that mean? How does that help us? Well, complementary means that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Now our reason. Well, notice I said angle 1 and angle 2 are complementary. What does that mean? Well, complementary means that the measures add up to 90 degrees. Our reason is because that's what the definition of complementary means. It's the definition of complementary. Now we can continue. Okay, that's as far as we can take that right now, but we do have another given up here. Angle 1 and angle 3 are complementary. And what's our reason for that? Well, because it says so on the paper. It was given. It's one of the givens. Now, there's not really any excuse for missing either of the givens. Givens always go in the proof, 1 or 2 or however many givens there are, and the reason for them is always given. Okay, so angle 1 and angle 3 are complementary. So what? What does that mean? Well, complementary means that the measure of angle 1 plus the measure of angle 3 is 90. And how do we know that? Well, because that's what complementary means. That's the definition of complementary. Now notice, to get line 2, we used line 1. So we don't need to use line 1 anymore. To get line 4, we used line 3. So we don't need to use line 3 anymore. That means that to continue the proof, we need to use lines 2 and 4 because we haven't used those yet. So the measure of angle 1 plus the measure of angle 2 equals 90. And the measure of angle 1 plus the measure of angle 3 equals 90. Well, notice, they're both equal to 90 degrees. And if they're both equal to 90 degrees, what that means is that the measure of angle 1 plus the measure of angle 2 up here, which is equal to 90, has to be equal to the measure of angle 1 plus the measure of angle 3, because they're both equal to 90 degrees. Now the reason. If two things are both equal to the same number, it means that the two expressions, or the two statements on the left, have to be equal. That's the transitive property. The transitive property, for example, says that if A is equal to B and B is equal to C, then A and C have to be equal. Line 6. Okay, so the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. Now I also like to keep an eye on where I'm going. What is my goal? My goal is to show that angle 1 is congruent to angle 3. Well, if angle 1 is congruent to angle 3, that means angle 2 and angle 3 have to have equal measures. So can we get there somehow from this statement? We have two things that are equal, but look at the left side and look at the right side. They actually have something in common. They both have a measure of angle 1. So what we can do is essentially subtract the measure of angle 1 from the left side and subtract it from the right side. What you do to one side, you have to do to the other. So if we subtract the measure of angle 1 from the left side, we're left with the measure of angle 2. If we subtract the measure of angle 1 from the right side, we're left with the measure of angle 3. Now the fact that we just subtracted something, the reason is called the subtraction property. And more specifically, it's the subtraction property of equality, because they're equal. They started equal and now they're equal at the end. Well, we're almost there now. One more step. If the measure of angle 2 is equal to the measure of angle 3, what does that mean? Well, that means that angle 2 is congruent to angle 3. And the reason for that is because of the definition of congruence. If angle 2 and angle 3 have the same measure, that means, by definition, what it means to be congruent, that angle 2 is congruent to angle 3. Now, once you have made it to the prove statement on line 7, you're done. Don't continue. Stop. Sorry about that. Here we go. Stop. Don't do any more. The very last line is always what you're trying to prove. Always. Guaranteed. Notice what word is not used on the right side of this proof is the word prove. Never, ever, ever in a proof is prove, this word right here, a reason. And it's tricky because given is a reason for the two statements that are given, but prove is never a reason. Now, here's the trick. This is the two-column proof, but you also need to be familiar with flow proofs. So here's the idea. If you can do a two-column proof, you can do a flow proof also. They are closely connected. It's just a matter of connecting the dots. So line 2, how did we know that the measure of angle 1 plus the measure of angle 2 equaled 90? Well, we used line 1. So what that means is in the flow proof, line 1 has to go first. So for example, it might look something like this. Line 1 says, angle 1 and angle 2 are complementary. And that goes in a box. And underneath the box is our reason. Well, our reason from above was given. Now line 1 up here at the top told us that line 2 was going to be true. So in our flow proof, from this first box, which was line 1, we need line 2. The measure of angle 1 plus the measure of angle 2 equals 90. Because this statement was a result of them being complementary. And the reason is the definition of complementary. Now notice though, line 3 in the 2-column proof, angle 1 and angle 3 are complementary. This statement was unrelated to the first two. I mean, it's another given, but it's not a result of angle 1 and angle 2 adding to 90 degrees. It's a different thought. So in our flow proof, this was one thought. Our next thought needs to go below it in a different line. So angle 1 and angle 3 are complementary. It's a different thought, so a different line. And that goes in a box. And our reason is the same reason from above, given. Now, so what? Angle 1 and angle 3 are complementary. What did that tell us? Well, that told us that the measure of angle 1 plus the measure of angle 3 equal 90 degrees. And the reason for that was the definition of complementary. Now look back at the 2-column proof. Once we had line 2 and we had line 4, we used those to get to line 5. That we knew the measure of angle 1 plus the measure of angle 2 equaled 90, and we knew the measure of angle 1 plus the measure of angle 3 equaled 90. So we took those two rows, those two lines, and we basically put them together to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. We used row 2 and row 4 to come up with row 5. In your 2-column proof, well, those locations are fairly important. Here's the information from row 2. Here's the information from row 4. They need to come together to give us the information in row 5. That is the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. Measure of angle 1 plus measure of angle 2 equals 90. So does the measure of angle 1 plus the measure of angle 3, which means these two left sides of these equations have to be equal. And just as before, the reason for that is the transitive property. Now, just as before, line 6 of the 2-column proof, we use the subtraction property of equality to say that the measure of angle 2 equaled the measure of angle 3. But row 6 was a result of row 5. So in our 2-column proof, in our flow proof, it comes off of this statement here. And we say the measure of angle 2 is equal to the measure of angle 3. And the reason we know that, just as before, is the subtraction property of equality. Finally, once you know the measure of angle 2 equals the measure of angle 3, you can make one more conclusion, and that is that angle 2 is congruent to angle 3. And just as before, the reason we know that is because of the definition of congruent. So lots of students argue that one method or the other is easier. that one method or the other is faster. But here's what you need to know. Some people prefer some methods over others. When I was in high school, I preferred the two-column proof. In college, I preferred the two-column proof. It was kind of my preference throughout my own education. But now that I'm a teacher, I see some value to the flow proof because it provides the visual aid of how the pieces actually connect together. It is up to you though. But look, the 7 statements and the 7 reasons in the two-column proof are also in the flow proof. 1, 2, 3, 4, 5, 6, 7. There's no more, there's no less. The only difference is that here you have a left column and a right column with labels at the top, and here you have boxes and arrows. The choice is ultimately yours. Let's try another proof. Here's a good one. We have angle ABE with C and D coming off on the inside, so ABC, CBD, DBE. And we are given BC bisects angle ABD. Ray BD bisects angle CBE, and we're trying to prove that ABC is congruent to angle DBE. Let's again start with the two-column proof. Statement and reason. All right, the statements can always start with the givens. So, statement 1, BC, ray BC, bisects angle ABD. And the reason is it's given. Now, I prefer at this point in time, as I said before, to use this given. So what? BC, this ray right here, bisects angle ABE. What does that mean? What does it mean to bisect? To bisect means to cut it into 2 equal pieces, 2 congruent pieces. And if you bisect an angle, you cut the angle into 2 congruent pieces. That means that those 2 angles are congruent. And that's what we can write on the next line. Angle ABC is congruent to angle CBD. How did we know that those were congruent? Well, we knew they were congruent because BC is the bisector. And that's the definition of bisector. Or you could say the definition of angle bisector. I like putting the word angle in there. It helps keep me focused on the fact that these are angles we're dealing with and not line segments. All right, a new given. Ray BD bisects angle CBE. This ray right here, BD, bisects angle CBE. Well, what does that mean? Right, given here for the reason. Well, what it means that BD bisects the angle is that the angle is cut into 2 congruent pieces, which means this piece right here, angle CBD is congruent to angle DBE. So that's angle CBD is congruent to angle DBE. And the reason that we knew these were congruent is because that's the definition of what it means to bisect. That's the definition of angle bisector. All right, now note, please notice, we used line 1 to create line 2. So we already used line 1. We don't need to worry about that anymore. We used line 3 to create line 4. So we already used line 3. We're done with that one. We somehow, though, need to use line 2 and line 4. Line 2 says angle ABC is congruent to angle CBD. Line 4 says angle CBD is congruent to angle DBE. Notice, both congruencies have angle CBD. What that means is that if these two angles are congruent, but these two angles are congruent also, angle ABC has to be congruent to DBE. Angle ABC has to be congruent to angle DBE. And the reason for that is the transitive property of equality, of congruency. The transitive property says if two things are congruent to the same item or the same angle or the same line segment or whatever it happens to be, then the pieces that are congruent to the third piece are also congruent. So if A is congruent to B and B is congruent to C, then A and C must be congruent. And notice here, at this point in time, we just reached what we were trying to prove, which means this is the last line of the proof. We're done. Now keep in mind, sometimes the givens are not separated. They might be on the same line. And how you're going to know that is sometimes there'll be two lines in the statement column for one given. There'll be two lines. That's not so you have more space to write. That's because they're two givens. In which case, line 1 and 3 could go together, and 2 and 4 would just follow separately. Now let's write this as the flow proof. This one's not too bad. It only has 5 statements, which means in our flow proof we'll have 5 boxes. We start with a given. Ray BC bisects angle ABD. In the box. And how do we know that? The reason goes underneath. Same reason as above. Given. Now, what did this given tell us? What did it allow us to conclude? Well, it allowed us to conclude that angle ABC is congruent to angle CBD. And the reason from above is the definition of angle bisector. Now keep in mind, line 3 from above, a new given. Every given is going on a separate line because it's a separate way to enter the problem, to begin the problem. It's a separate thought process. So line 3 from above goes on a separate line. Ray BD bisects angle CBE. In a box, and the reason, given. Now the second given, line 3 from above, allowed us to conclude that angle CBD is congruent to angle DBE. And the reason, again, we knew that it was a bisector, and that's the definition of angle bisector. Now we've covered 4 of the lines, 4 of the rows from the 2-column proof, and 4 of the boxes. We only have 1 more to go. Now keep in mind, row 5 from above was able to be concluded from row 2 and row 4. Well, in the 2-column proof, row 2 is up here, row 4 is down here. 5 was a result of it. ABC is congruent to CBD, CBD is congruent to DBE, which means angle ABC is congruent to angle DBE. And the reason, as we had before, was the transitive property of congruency. Not every proof our first proof was 7 lines long. Not every proof is 7 lines long. This one was 5, 2 of which were the given, and the 5th row was what we were trying to prove. Much simpler than the first one, much shorter than the first one, but just a different proof to deal with. Third proof. A little bit longer. Here we go. The measure of angle 2 is equal to the measure of angle 3. That's what's given. And we're trying to prove that the measure of angle 1 equals the measure of angle 4. For this proof, we're just going to do the 2-column proof for space on the paper. It's a little bit longer than the others. And we're going to start 2 columns, just as before, the statement and reason. Now here, the given is oftentimes where we start, but notice there's only one given. Measure of angle 2 is equal to measure of angle 3. That's not going to get us very far. There's nothing we can really conclude about that. So you have to look at the picture. Is there anything about this picture that they're secretly telling us? Well, look at angle 1 and angle 2. What do you notice about angle 1 and angle 2? Well, I see that they're a linear pair, which means if they're a linear pair, that the measure of angle 1 and the measure of angle 2, they have to be supplementary. Angle 1 and angle 2. They have to add to 180 degrees because of this straight line. So what we do is we start by saying angle 1 and angle 2 are supplementary. And the reason, it's a little tricky. It's called the linear pair postulate. The linear pair postulate says that if you have a linear pair, if you have 2 angles that together make a straight line, then they are supplementary. Okay, so what? They're supplementary. What does that mean? Well, that means that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. And how do we know they have to add up to 180? Well, because they're supplementary, and that's what supplementary means. If you find yourself saying, because that's what it means, that's what the word is, then you're probably looking for a definition for your reason. The definition of supplementary. Now that gives us something we can work with, but notice over here we have the same sort of thing going on. 3 and 4, angle 3 and angle 4 make a straight line, they make a linear pair, which means angle 3 and angle 4 are also supplementary. And our reason, just as before, the linear pair postulate. So what's it mean? They're supplementary. How does that help us? Well, it helps us because since they're supplementary, that means the measure of angle 3 plus the measure of angle 4 equals 180. And again, the reason we know that is because of the definition of supplementary. Now, we used line 1 to get line 2, so we already used line 1. Line 3 we used to get line 4. We already used line 3. So we haven't used line 2 or line 4 yet. We need to use those to get number 5, to get row 5. So the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 3 plus the measure of angle 4 equals 180. Well, the fact that row 2 equals 180 and so does row 4 means that the left side of these two equations also must be equal. The measure of angle 1 plus the measure of angle 2 must equal the measure of angle 3 plus the measure of angle 4. The reason is the transitive property. Now, oftentimes, the transitive property can be interchanged with substitution property. They both more or less mean the same thing. Transitive sounds a little bit more mathematical, but substitution, the substitution property is oftentimes a little more accessible when you're trying to remember the reason. Okay, so the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 and the measure of angle 4. Look at what we're trying to get to. We're trying to prove that the measure of angle 1 equals the measure of angle 4. So we're close here. We have a measure of angle 1 on the left side and we have a measure of angle 4 on the right side. The issue is that the left side has an angle 2 and the right side has an angle 3. Those are different, which means the subtraction property is not going to work. The subtraction property only works if you're subtracting the same thing from both sides. Well, as we've gone through this proof, there's a pretty big thing that we have so far ignored, and that's the given. We haven't used the given yet. The given is that the measure of angle 2 is equal to the measure of angle 3. So let's go ahead and put that down. The measure of angle 2 equals the measure of angle 3, and that's given. Your givens don't always have to go first. You can save them until they're convenient to you. You can also just say them at the beginning and get them out of the way. I personally like to save them until we use them so that they don't get lost inside the proof. Now you have a little bit of choice here. The measure of angle 2 is equal to the measure of angle 3, so we can substitute one of those into line 5. Notice, to get line 5, we used line 2 and we used line 4. So we don't have to use those anymore. But we still haven't used line 5 or line 6. So I'm going to say I'm leaving the left side of line 5 alone. But the right side, instead of writing the measure of angle 3, I'm going to substitute in the measure of angle 2. Since angle 2 and angle 3 have the same measure. Instead of measure of angle 3, I'm going to write measure of angle 2. And I just use line 5 and I use line 6. And the reason, I even said the word, I'm substituting in measure of angle 2 instead of measure of angle 3. That's the substitution property. All right, now this should look fairly familiar because we saw this earlier in a proof. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 4. Both the left side and the right side of the equal sign have a measure of angle 2. And when both sides have a measure of angle 2, you can subtract it from both the left and the right side, which leaves you with the measure of angle 1 equals the measure of angle 4. Subtracting something like the measure of angle 2 from the left side and the right side of the equal sign is called the subtraction property of equality. And to get line 8, we use line 7. So we've used all the lines for our proof. Now it's my advice for you, as you go through these proofs, The more proofs you see, the better off you're going to be, because sometimes they're tricks like putting the given further down in the proof. Some of the tricks I like to use aren't tricks that other teachers use. Some of the tricks the other teachers use, I don't use. And part of it's just your own personal style. But the more proofs you see, the better off you'll be. I also suggest that as you go through these proofs, great, you watched me do the proof. I would suggest you rewind the video to where it's blank, to where maybe it looks like this, and you try the proof on your own. If you can solve the proof on your own, then that's wonderful. You're good. But if you try to solve the proof on your own and you struggle, you can't make it through the proof, watch the video again. Read the proof again, study the proof, and then try it on your own again. Reading through the proof is often not enough. You do have to practice. You have to have your properties memorized, and the more times you see pictures like this, you know to say that they're supplementary. That means they add to 180. You start to pick up on those patterns. The more proofs you do, the better off you'll be for the test.